Year 7, yesterday we started to look at index notation, or taking a number to a certain power. Today I want to just go through one particular part of that and the opposite. And that's to do with squares and square roots to start with. So to square a number means raising it to the power of 2, multiplying it by itself. So 7 squared is equal to 7 times 7, or 49 would be the answer. When you get the number 49, what that actually means is you found a square number or a perfect square, because it works, all right? There's a number of other ones. This is the next bit though. The opposite of squaring a number is to find the square root. That's the symbol for it that we use, but we write it like that. So I'm doing the reverse, you might say. The square root of 49 is equal to 7. Or what number multiplied by itself equals 49? Hopefully you've come across that before. But there's also cubes and cube roots. Same concept though. Cubing a number means raising it to the power of 3. For example, 7 to the power of 3 is equal to 7 times 7 times 7. And the answer is 343. 343 is called a cube number, or a perfect cube, just like with the squares. Okay? But again, we can also do the reverse. The opposite of cubing a number is to find the cubed root. In fact, as I look, that symbol is wrong. It should have a 3 there. The cubed root, that's how you can tell it's the cubed root. There's a little 3 there. Just above that of 343 is 7. We're going backwards. What times itself again equals 343. Cubes, cube roots, square roots. Should be straightforward now, hopefully. So let's have a look at some examples. So I'm doing the first question, is the square root of 64. What number multiplied by itself equals 64? You're right. Someone got it straight away. The answer is 8, because 8 times 8 equals 64. Well, here it is with the symbol. What's the square root of 25?
5.
Excellent. 5 times 5 equals 25. This one's a little bit trickier. The cube root of 125. Now, we may not know that. Okay, it's not something we normally do off the top of our heads. But have a think about it. It's got a 5 on the end. So it's probably got something to do with a 5. What do you think it might be? Yep, having a go. All right, that's all right. Thanks for having a go. In fact, it's 5. It is just 5. Because 5 times 5 is 25. We know that. Multiply 25 by 5 and you get 125. All right, let's do an easy one. Cubed root of 8. Think of a number. It's got to be a lot less than 8. That when you multiply it by itself, and then again, it equals 8. What do you think?
2.
Absolutely. Well done. 2 times 2 is 4. Times 2 is 8. So the cubed root of 8 is 2. The last question here asks us to estimate the value of the square root of 40. Notice 40 is not a perfect square. It's not the square of a number. What are the two numbers either side that are perfect squares? What do you think of that's near 40 but not that is a perfect square, a number multiplied by itself? Okay, I'm looking around the room seeing some blankness. It helps if we know our squares a little bit. So I could do 1 squared, which is equal to 1. What's 2 squared equal to?
4.
Excellent.
17.
What's 3 squared equal to?
9.
Yep, good. What's 4 squared equal to?
16.
16. We know these, that's good. 5 squared, we've already got that up there a few times, that's 25. 6 squared, what's that equal to? Yeah. 36, good work. And 7 squared, it was 2 slides ago, but 49. We're asking about this question here, 40, square root of 40. It's somewhere in between those two. Which one is it closer to?
6.
Yes, it is closer to 6. All right? So it's going to be less than 6.5 because we're closer to 6. In fact, if you were to estimate, you might go 6.3 or 6.4. I know it's actually very close to 6.3. So we're just after an estimate there. Just have a look and have a guess. But we can do that sort of thing as well. So that's square roots, cube roots. We're just reversing the process of squaring or cubing. Hopefully we can do that. We're going to get in, have some practice, and keep working hard on our maths.